Hi, third grade friends. Welcome back for another math lesson with Miss Paglarani. Today we're going to be shifting gears a little bit from working with rulers to reading line plot graphs. We're not going to waste any time. We're going to jump right in. So on our agenda today, we're going to be watching a Khan Academy video. We'll do 2 practice problems together, and then it'll be time for you to work on your independent practice and your exit ticket. Now, before we watch the video, I want you to think to yourself what you know about graphs. This year we've worked with bar graphs, we've worked with pictographs, but what do they tell us? If you need to pause the video to take a second to think, that's totally okay. If you said that they help us to understand and organize information in a picture so that we don't have to read it in like a big paragraph, you're right. We'll see graphs all over the place and in many different types of jobs, like meteorologists, or you might know them as weather people, doctors, architects, teachers, and so many more. All right, let's watch that video.
Let's say we're having a birthday party, and these are the kids at the birthday party. And all of the kids, they have a bunch of different ages. And what we are curious about is how many kids of each age do we have? Well, to help think about that, we can draw what is called a line plot. And I've always viewed the term line plot a bit confusing because in my brain you use a lot more dots than you use lines. But let's look at what a line plot is. So what I will do is I will draw, I guess this involves a line right over here. I'll draw a line down here, and then I'll create buckets for each of the ages. So let's see, I have students here from age 3 all the way to age 7.
So right there, he found the youngest and the oldest. So when we start making our own line plots, we're always going to have to find the smallest number and the largest number in the data set when we're making that line plot.
Say age 3, age 4, age 5, age 6, and age 7. I don't have to go to 2 or I don't have to go to 8. There aren't any kids in those ages, although I could if I want. And then I look at, well, how many kids do I have of each age? Well, I have one person attending the party, Dia. She's age 3. So I might put an X here, or I could put a dot here. Different line.
So what he's doing is he's helping us to find the frequency. What does frequency mean? Think in your brain. If we say that something happens frequently, it means that it happens often. So we're trying to figure out how often something is showing up in our set of information. So for example, I could find the frequency of how many scholars in a class were wearing a shirt that had something red on it.
Plots would put different things here, but that shows me that I have this partier is age 3 right over here. Now I have Imran, age 5, so that's someone right over here who would be age 5. You could think of this dot. This represents Imran, who's age 5. Then you have Surya, who's also age 5. So he's also age 5, so that means we have a second person at the party who is age 5. So under age 5, we now have 2 people. This is Imran and this is Surya. Then you have Jasper, who is 6. So that's one person who is age 6. Then you also have Vikram, who is age 6. Oops, let me do that in that same color. We also have Vikram, who is age 6. So let's put him in the age 6 bucket. Then we have Luke, who is 7. Luke, who is 7. So that would be a dot right over there. And then finally I have Anya, who's also age 6. So just like that, I was able to take all of the data that I have in this table, and I'm able to put it on this line plot. And the reason why this line plot is useful,
if you're wondering what he meant when he said data, that's just a fancy word for the information that's in our chart here.
helps us look at, well, how many of each age do we have? It might be a little bit more confusing to just look at the table here. Because when you look at the line plot, it's very clear. Hey, look, there's no one here who is age 4. And look, we have the most people who are age 6. And if we asked ourselves a question, well, how many, if you didn't even have this, actually, let me just even take it away. If we didn't even have that there, if we didn't have the table, and we just had the line plot, and if someone said, hey, look, these are ages right over here. This is our ages in years old.
I might even go a little bit further and label what each dot represents. I think he got a little bit tricked here and forgot to label each dot represents one child who attended the party.
And each dot represents a student who's at the party. So based on this line plot, how many people are more than 5 years old? Well, you could look at this and you could say, okay, more than 5 years old. That would be 6 years old or 7 years old. It's not.
Notice how he didn't get tricked there. He didn't include 5 because the question asked who are older than 5.
Anyone who's 8, 9, 10, 11, and on and on and on and on. So let's look at all the dots. Let's all look at all the dots here that are more than 5 years old. There are 3 6-year-olds and there's 1 7-year-old. So there are 1, 2, 3, 4 people who are older than 5 years old. You could go the other way around. You could say how many people are less than 5 years old. Well, then you could say, okay, less than 5 years old would be either 3 years old or 4 years old. And when you look at those dots, you see there's only one dot. Only one person attending the party is less than 5 years old. Hopefully you found that interesting.
All right, so we know that when we're working with line plots, we need to have a set of information about something, or we could call it data if we want to use a really good math word. And then we use our line plot to track the frequency or how often something happened within this set by using either dots or X's. I like X's. Whoops.
Let's say we're...
All right, let's jump into our first practice problem together. I've created some steps here like before to help me solve problems with line plots. So the first thing I need to do is look at the title. What kind of information is this graph telling me about? Well, I see that the title says time spent outside over the weekend. Okay, so it looks like it's in hours down here, so either 1 hour, 2 hours, 3 hours, or 4 hours spent outside over the weekend. And I know that the symbol, what does each symbol or X represent? One person. So I know that these numbers are hours, and each X is a person who spent that number of hours outside over the weekend. It's really important when we're reading line plots to use the labels in the key to help you understand what's going on. Now let's answer the questions. Fill in the missing values in the line plot. Oh yeah, I didn't even realize at first that there are hash marks here that have no number underneath. What comes between 1 and 2? Well, I know when I count by whole numbers, 1, 2, 3, 4, I don't hear anything come between 1 and 2. So I'm going to have to use my knowledge of fractions. Right. What comes halfway between 1 and 2? If you said 1.5, you are correct. So I'm going to add that in there. Oops, 1 and 1/2. We'll stretch it out a little bit so it looks right. There we go. Okay, so if we had 1 and 1/2 there, what do you think would go here? Between 2 and 3. If you said 2.5, you're right. And then between 3, and 4 would be 3.5. Awesome. All right, I'm going to double check as I go. So, done. What is the most frequent amount of time spent outside. Now, most frequent means I'm looking for the one with the most X's or dots, right? So the one that happened the most amount of times, or in this case, had the most people. So let's see, not 1, not 1.5. Ooh, 2 looks pretty tall there. There's a lot of X's. 1, 2, 3, 4, 5, 6 X's. Yep, that looks taller than any other amount of time spent outside. So the most frequent amount of time spent outside was 2. Okay, what about the least frequent amount of time spent outside? So I'm looking for the hours that have the least amount of X's. Looks like 4. 4 has 1 X. That's lower than any other amount of X's I see on here. So 4 hours, that's a long time to spend outside too. So I bet you that's why there weren't as many people that spent that much time outside. How many kids were surveyed? Ooh, this is important. I have to make sure I know what I'm counting here. So it looks like kids or people are represented by an X. So I have to count up all of the X's to find out how many kids were in the whole survey. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. All right, 24 kids. All right, let's double check. Did I answer all of the questions? Yep, I did just that. All right, let's go back to our practice problem number 2. All right, let's go to practice problem number 2. Again, I have my steps here to help me solve this problem. First, I have to look at the title. So I know that this graph is telling me about the heights of children on a 3rd grade basketball team. That'd be fun if we had a basketball team. What does each symbol represent? Well, I know that each X, just like in our last problem, represents a person or a child. And at the bottom, these are the heights, and our unit is inches. Again, it's really important to use those labels and the key to help you understand what's going on in the problem. Then we'll answer the questions. So what is the most frequent height for children on the team? Again, when we're looking for most frequent, we're looking for the one that had the most kids at that height. Let's see. Looking across all the options here, and it seems to me like 52 and 53.5 have the most, and it is a tie. Right, so it's a tie between 52 and 53.5. How many children are on the basketball team? We had a question just like this in the last problem, so we should be good. Remember, when it's asking how many children are on the basketball team, I know that the X's represent the children, so I need to count all of the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Wow, that's a pretty big basketball team. All right. How many children are less than 53 inches tall? It says don't get tricked. Why did I put that there? Don't get tricked. If you said it's because we want to make sure that we don't include 53, you're right. sometimes people get tricked on questions like this and they say less than 53. Okay, so it's the ones that are on 53, 52, 52 and a half, 52, but the question says less than 53. 53 is the number 53. It's not less than 53. All right, I am going to put a box around all of the different heights that we are going to include that are less than 53. Let me make this transparent. There we go. Okay, so 52 and 1/2 is less than 53. 52 is less than 53. 51 and a half is less than 53. And 51 is less than 53. Actually, you know what? I think I'm just going to make this one big box. That's probably a little bit clearer for you. So we're looking at just that part of our line plot. Okay, so I have to make sure that I'm counting the children. 1, 2, 3, 4, 5, and 6. The coach says 51 and a half is the least frequent. Is he correct? Take a second to think in your brain. If you need to pause the video, totally okay. It looks to me like it would be the least frequent because there's no children who were that height. But to be the least frequent, it has to have happened at all. So if it has 0 children, it's like it didn't happen. There were no children that were that height, so it can't be the least frequent. So actually, the least frequent would be the ones that had the heights that had 1 person. So 52, 54, and 55, because they had at least 1 child that was that height, but it was still less children than the other heights. All right. Sorry, coach. You are not correct. Let's double check. Did I answer all of my questions? Yep, awesome. All right. Now that we've done our practice problems together, it is time for your independent practice. So I'll click into that real quick just so you can see what it looks like. Again, don't forget to go to your Google Classroom account, and then when you click into the assignment, it will have this title, Independent Practice, Reading Line Plots. When you're done with this page, don't forget to press Turn In. There'll be a little Turn In button up here in the corner. And for these problems, you're going to type your answer on the side. So what is the line plot telling us about? It's telling us about how many caterpillars are 3 1/4 centimeters long. 78. I'm just kidding. That's too many caterpillars. All right. Then when you're finished with that, you're going to go on to your, exit ticket. Now, please make sure that you turn in your exit ticket only 1 time. Take your time while you're working on it. If you make a mistake, that's okay. Just reach out to your teacher, but you don't need to submit it 2, 3, or 4 times. Just 1 time is good for us. I'll take you into it so you have a little preview. Again, you're going to find this on your Google Classroom. You can also find the links to these below the YouTube video. Make sure that you click, I think it says see more, and then you'll be able to see the links. All right, so here I've made it all multiple choice today so that you won't have any issues with it marking correct answers wrong. I know we've had some issues with that with some of the short answer questions, so I kept it all multiple choice today. When you're done, you'll click submit. All right, friends. One last reminder. Tomorrow, Friday, is a catch-up day, so there won't be a new math video. Use this time to get caught up on any of your assignments and reach out to your teachers if you need any help. All right, friends, see you soon.